Welcome to episode 45 of FTCE Seminar, a teacher certification podcast. I'm your host, Mercedes Musto. Today, we will be talking about some mathematical concepts to help you prepare for the FTCE General Knowledge Mathematics subtest. Math, that's right. And today we're going to identify and classify simple 2D and 3D figures, like in a geometric way. Yeah, you know, two-dimensional or 2D figures such as triangles, squares, or even circles. Yeah, those things. And get this, three-dimensional or 3D figures such as cubes, cylinders, and prisms. Remember that stuff? Kind of, sort of? Okay, great. So let's get started. Concept 1, classifying simple 2D and 3D figures. Let's start with the idea of dimensions. Imagine you are holding a flat sheet of paper. That's the 2D world. Why? Because the paper has two dimensions, length and width. Think of 2D shapes like squares, circles, and triangles as a kind of flat figure that lives in the dimension called the flatland. Yeah. Okay. But what if we crumple that paper? Suddenly it gains a third dimension. It still has length, it still has width, but now it's no longer flat. It also has height. That's the realm of 3D shapes. 3D shapes bust out of flatland and become cubes, spheres, and pyramids. These awesome figures all exist in this exciting new world where length meets width and height. Okay. Keeping the momentum, let's take a deep dive into the mathematical properties that further define these shapes. In 2D, we focus on properties like lines and angles. Lines can be straight like a square, curved like a circle, or a combination of both like a semicircle. Angles are formed where these two lines meet, and angles are measured in degrees. See, squares, for example, have 4 equal sides and 4 right angles, which are 90 degrees each. But in 3D, things get a bit more complex. See, we still have lines and angles, but we also have faces, edges, and vertices. Faces are flat surfaces that make up the shape, like the squares on a cube. Edges are where two faces meet, and vertices are where the pointy little corners where edges come together. For example, a tetrahedron, aka triangular base prism, has 4 faces, 6 edges, and 4 vertices, whereas a cube has 6 faces, 12 edges, and 8 vertices. Here's where things get really cool. These mathematical properties help us identify and classify geometric shapes and figures. For example, a trapezoid in 2D is a straight-lined figure with one exact pair of parallel lines. In another example, a triangle is a simple polygon with 3 sides. Okay, stay with me now. If the triangle has 2 sides and 2 angles that are the same, it is an isosceles triangle. But if all sides and all angles are different, it's a scalene triangle. See what I mean by being able to identify and classify figures by their properties? But the geometric journey doesn't stop there. We can use these properties to calculate areas and volumes. Area in 2D refers to the amount of space a flat shape occupies. We can calculate it using formulas based on length and width. For example, for the area of a rectangle that measures 3 feet by 10 feet, we would simply multiply the 3 times 10 to get the area of 30 square feet. That's area equals length times width. In 3D, we calculate volume because remember, 3-dimensional figures are a bit more complex. Complex how? Well, to begin with, we added a third dimension. Think of volume as the amount of space a solid shape occupies. How do we calculate volume? Great question. We use formulas based on the shape's properties. Sticking with the rectangle from the previous question, what would the calculated volume of a rectangular prism that had a width of 3 feet, a length of 10 feet, and a height of 5 feet B. So in this case, our formula would be volume equals length times width times height. So that volume would equals 3 times 10 times 5, and that equals 150 cubic feet. Let's review. Remember that we called the 2D world the flatland. Why? Because the figures had 2 dimensions, length and width. Some common 2D shapes are circles, squares, and triangles. Yeah. Okay, but what about the realm of the 3rd dimension? It still has length, it still has width, but now it's no longer flat because it has height. Some 3D shapes are cubes, spheres, and pyramids. Lastly, when we calculate the area of a 2D shape, we can simply use the formula for area, which area equals length times width. But for 3D shapes, we're calculating what's called volume, and there are several different formulas for calculating volume based on the mathematical properties of the figure. Understanding these concepts will help you pass the geometry section of the FTCE GK mathematics subtest. So next time you see a triangle or a sphere, remember that geometry isn't just about fancy shapes. It's basically a language that helps us understand the world in all its 2 or 3-dimensional glory. For more practice with math strategies, visit ftceseminar.com. The important thing is to start studying today so you can pass your teacher certification exam. Well, what are you waiting for? Check us out on YouTube at FTCE Seminar and start studying today. This podcast was recorded at the Pickens Multimedia Studio at the University of West Florida. This podcast is listener supported. Contributions can be made via the listener support link on Spotify, or you can buy me a coffee at FTCE Seminar. This is your host, Mercedes Musto. Join me again on FTCE Seminar, a teacher certification podcast, so you can pass the FTCE.